Hey, I had a little memory issue with the iPad I was using there to record this, and I got cut off in the middle of 19 here, so we will resume here. So we have a graph of f prime, and we're looking for relative maxima. Now, maximums happen when f prime goes from positive to negative. Okay, so where does this go from positive to negative? This goes from positive to negative here. Positive to negative. I'm not talking about this going from positive to negative. That's like the sucker answer that we talked about in the last question. Nobody's ever going to ask you where are the maximums of this, and you're like, oh, there's one and there's one. No, that's nobody's interested in asking you that. This is the graph of the derivative, so we need to know these are the derivatives, and right here they're going from positive values to negative values. So that is a maximum, and it looks like that's the only one because it doesn't cross here, it just grazes it. And if this had equal signs here, then as this was increasing up to this point, if there was an equal sign there, then remember the checking the endpoints thing, there would be a relative maximum because the function would be going up, increasing up to a point, and then it would stop there. Well, that's a relative maximum, right? But it's not. It's an open interval. So that means it's an open circle, and that means that is not a maximum because you never quite actually get there. So there's only one. Right there. Number 20. Table above gives values of f and g, and we got this h function, which is defined to be this, and we want to find h prime of 1. So this is a product of those two things. So I'm going to find h prime using the product rule. H prime of x is equal to the derivative of the first. The derivative of 2f of x is 2 f prime of x, and the derivative of 3 is 0, times the second plus the first times the derivative of the second. Derivative of 1 is 0, derivative of that is g prime of x. All right? And then plugging 1 into all this. So let's see, I've got 2 times f prime of 1. F prime of 1 is negative 2. And then 1 plus g of 1 is negative 3. Plus 2 times f of 1 is 3. Times g prime of 1 is 4. Okay, got to do some math now. So negative 4 here times negative 2 plus 2 times 3 is 6 plus 3 is 9 times 4. So that's 8 plus 9 times 4 is 36. So it's like 44 is the answer. Number 21. Functions f and g are differentiable for all x. F of g of x is equal to x. Okay, so this is a little tricky here. What you have to understand and realize, this is something... When you learned about inverse functions in, I don't know, like Algebra 2 or something, I don't know if it was presented to you in this way or not, but one way of defining an inverse function is to say, like, if you take a function and you compose it with another function, this is not multiplying, this is like f of g of x. If you do a function to whatever g did and you get back to the original thing, and that works both ways, this means f and g are inverses. So once you recognize that, this is one of those little inverse problems where, so if f and g are inverses of each other, that means if the point 3,8 is on the f function, then the point 8,3 is on the g function, because they're inverses of each other. And furthermore, that if I know that f prime of 3 is 9, so that means if the slope of this at 3 is 9, then when you go to the corresponding point on the derivative, then rise over run became run over rise, things get flipped over, so g prime of 8 is equal to 1/9. Right, it's one of those inverse problems. Okay, so and where did that happen? That was in section 4.3, if you needed to go back and look at that. Felt like you needed to do that. So g of 8 is 3. That's these. And g prime of 8 is 1/9. So that's answer choice E. All right, I think I need a calculator here. Where's my... There it is. Calculator. Okay, so the first derivative of a function is given by this. How many points of inflection does the graph of f have? Now, if you're thinking, oh, I need the second derivative, so I'm going to take the second derivative, you could do that, but I'm not going to do that because I know how to find if this is the derivative, then on the graph of a derivative, I know that the inflection points are the maximums and minimums of that. How do I know that? My calculus teacher told me. Yeah, sure, whatever, but you probably weren't listening to him when he said it. So why would these be the inflection points? Because an inflection point is where f double prime, where the second derivative changes sign. Now, the sign of the second derivative is the slope of the first derivative, right? Like here you could say, well, is the second derivative positive or negative? Well, this derivative has a positive slope here, which means f double prime is positive. So if it changes from increasing to decreasing on the derivative, that's an inflection point. So that's what I'm going to do. I'm going to graph this, and I'm going to look for the maximums and minimums. And I'm going to graph it on that interval only. And I'm going to make sure that I am in radian mode, because I'm in calculus class. All right, so x minus 4e to the negative sine of 2x. Okay, x minus 4e to the negative sine of 2x. And before I hit graph, I'm going to go to the window, and I'm going to go from 0 to 2 pi. And y, negative 10 to 10, I don't know, sure. We can try that and see how that looks. And I can adjust that if I need to. There's 1, 2, 3, 4. So 1, 2, 3, 4 maximums and minimums. It's kind of a nice looking graph, isn't it? Like that. 1, 2, 3, 4. 1, 2, 3, 4. Those are the places where the second derivative changes from positive to negative, or vice versa. So positive to negative, negative to positive, positive to negative, negative to positive. All right, another maybe calculator one. Those numbers don't look too bad. Function f is differentiable and has values shown in the table above. Both f and f prime are strictly increasing on the interval from 0 to 5. Okay, so f, the values of f and f prime, if I knew what those were, they're strictly increasing. They're getting bigger. Okay, what does that mean? Why are they telling me that? So which of the following could be the value of f prime of 3? Okay, so here, what do we think the slope here would be? Well, an approximation for that slope, I could actually find the, I could use the points around this, right, and find the average slope and say, well, that's a pretty good approximation for this, right? Could do that, couldn't I? Sure. So let's do that and see what how things look there. So rise over run. Make a little fraction thingy here. So 48.05 minus 39.2 over 3.1 minus 2.8. Okay. So which one of these could be the value of f prime of 3? Excuse me. If this is this information here that f prime is strictly increasing is important. The slopes are strictly increasing, so it definitely can't be less than this, right? I wonder if this, you know what I'm thinking is, this question might actually involve a little bit of mean value theorem, which is in section 5.7, which we haven't quite got to yet. I'm trying to think if there's a way that we can sort of reason through this with just what you know. And I'm not sure that there is. So I'm going to talk you through this anyway because I feel like it's my job as a calculus teacher. So what I'm going to do is I'm going to actually find the average slope from here to here and here to here, right? So do that. The same thing again. I'm going to find my little fraction function there. 45 minus 39.2, and then 3, that's just 2. Okay, so the average slope right here, oops, what did I do wrong? Oh, it's 0.2, so it'd be 29. And then the average slope here would be 3.05. That's that minus that over 0.1. So 30.5. So what this means is the mean value theorem, which you're going to learn about in section 5.7, says that if you have a differentiable curve, if it's going from here to here and it's smooth, which is what differentiable means, then somewhere in between here and here, that average slope, like just y minus y over x minus x, what we just did there, that average slope has to actually happen. Like the derivative has to equal that. So what that means here is that somewhere between 2.8 and 3.0, this thing has to have a slope of 29. And then somewhere between 3 and 3.1, it's got to have a slope of 30.5. And if it's only increasing, then at 3, it's got to be in between these two. So that's answer choice D. So I'm sorry about that. That's this is MVT. When I looked at this, I just was kind of glancing through these and saying, oh yeah, they can do that, they can do that. I just misjudged this one. I didn't actually work through the whole thing and see what we needed there. So oopsie. If you got it right, good job.